All right, middles, it's your turn. Here is your problem of the day. Compare 2/4 and 3/6. Remember, all this week, we have been using fraction strips to compare our numbers. Let's start with 2/4. Which of our fraction strips would we use to represent 2/4? Did you say the 1/4 pieces? If you did, you're absolutely correct. How do you know? That's right. Our denominator, or the number on the bottom of our fraction, tells us which of our tiles to use. Well, how many 1/4 tiles do we need to use to represent 2/4? That's right. We need 2. And we know that because our numerator is 2. 1/4, 2/4. Great job. Our next number that we're going to represent is 3/6. Which of our fraction strips are we going to use to represent 3/6, and how do you know? Did you say that we're going to use the 1/6 strips because our denominator is 6? If you did, you're absolutely correct. Well, how many of our 1/6 strips do we need to represent 3/6? Did you say 3? If you did, you're right on. 1/6, 2/6, 3/6. This looks a little different than any of our problems that we've done so far this week. Did you notice something? Both of those sets of fraction strips are the same length. This means that 2/4 and 3/6 are actually equivalent. What do you think that it means to be equivalent? Well, to be equivalent means that 2/4 and 3/6 are equal. So they are exactly the same. Great job, middles. All right, senior scholars, here's your problem. Remember, all this week we have been converting between various units of measurement, and we've been doing that via word problem. Our problem today says, Mr. Jeffries is buying water by the gallon for field day. He estimates that each student in the class will drink 2 cups of water. If there are 30 students in class, how many gallons of water will Mr. Jeffries buy? Well, first, let's figure out what 2 units we're going to need to convert between. I see gallons. Can you find the other unit? That's right, it's cups. And who remembers which of our friends is going to help us to do this conversion? That's right, my friend, the gallon man. Well, let's start by figuring out how many cups are in 1 gallon. Well, where's the gallon on our friend Gallon Man? That's right, it's the body. It's the biggest unit here. Well, how many cups are in a gallon? Well, we can take a look at Mr. Gallon's arms, and he's got 4 cups on each side, so 4 plus 4 is 8. And then we've got another 4 cups on each of his feet. So 4, 8, 12, 16. So we know that 1 gallon is equal to 16 cups. So what questions might we ask ourselves to solve this problem? The first question I would ask myself is how many cups of water will the entire class need? Well, let's take a look at our problem. There are 30 students in the class, and each student drinks 2 cups of water. So how can we figure out how much water he needs in cups? Did you say multiply 30 times 2? If you did, you're absolutely correct. And 30 times 2 is 60 cups. So the class needs 60 cups of water. Well, what's another question we might ask ourselves? Did you say how many gallons are equivalent to 60 cups? If you did, you're correct. Well, how are we going to figure that out? What if we divide 60 divided by 60 divided by 16? Well, let's solve that together. 16 into 60. How many times does 16 go into 60? Did you say 3 times? If you did, you're correct. Well, what's the next step when we're dividing using the standard algorithm? That's right, we're going to multiply 16 times 3. Well, 16 times 3 is 48. What do we do next? You guessed it, we're going to subtract. 60 minus 48 is 12. And because we have a remainder and we are in 4th and 5th grade, we turn that remainder into a fraction. And so our answer is that 3 and 12, 16 gallons is equal to 60 cups. Can we simplify this fraction? We absolutely can. 12/16 is equal to 3/4 because 4 goes evenly into each of these numbers. So are there any other questions we need to ask ourselves in order to solve our problem? How about how many gallons of water will Mr. Jeffries have to buy? Well, we know that 3 and 3/4 gallons of water will make sure that we have enough water for everyone. But can Mr. Jeffries go to the store and say he wants 3 and 3/4 gallons of water? No, he cannot. And so we're going to do some rounding here. Which direction do you think we need to round if we want to make sure we have enough water for the entire class? That's right, we'd have to round up. So where would we round 3 and 3/4 to? You guessed it, the nearest whole. And the nearest whole is 4 gallons. Great job, senior scholars. Well, thank you guys so much for joining me today on Calendar Math with Miss Udo. Tomorrow is challenge day, and I look forward to posting the challenge problem for you all, having you solve it for a chance to win some really cool prizes. Until tomorrow, see ya.